Today I want to talk to you about a breeding program that we're integrated in across the United States. And we're looking at screening certain germplasm lines of cotton for resistance to Fusarium wilt. Fusarium wilt's an important disease in cotton. It's not a widespread disease in many fields, but where it is a problem, it's a huge issue. It can cause severe losses in aggregated locations, depending on where you're at. The real reason that Fusarium wilt has become a problem in cotton and has kind of come in on the radar is because of certain races of the pathogen. There are a few races. One in particular is race 4. Race 4 is a very aggressive pathogen. It can cause severe yield losses in cotton, and it can actually infect the cotton without a nematode interaction. Most races that are indicative to Georgia do need a nematode interaction, whereas race 4 does not. Race 4 was significantly isolated to Northern California until recently. It was identified in Texas. So our breeding approach is to screen germplasm lines for that resistance primarily before race 4 reaches Georgia, if it does, and also to combat the pathogen races that we have here. So the reason that this research is so important in cotton is primarily foliar diseases are very easy to control with fungicides and chemical treatments, whereas Fusarium wilt, being a soil-borne pathogen, it's very difficult to control with any fungicide methods or fumigant methods, so host plant resistance is very important. In this plot, we are looking at variable germplasm lines. Some are obsolete varieties and some are exotic wild-type cotton. So our main goal in this research is to identify germplasm and genetics that could give us host plant resistance later in the future. So our primary goal is to integrate genetics that we find in these germplasm lines and integrate that later down the road into an elite variety that can be grown commercially that is totally resistant to Fusarium wilt. So our hopes are in the future that we can take some of the knowledge that we find from screening germplasm and hopefully one day make some crosses to find some heterosis of disease resistance from these germplasm lines, and then maybe even later identify exactly what genes are responsible for the resistance.